Good evening, class. We are going to finish this section, or better yet, this chapter dealing with sequences and series. We covered the main part of this chapter. It's about sequences and series, arithmetic sequences, geometric sequences, and binomial theorem. To refresh your memory about the vector properties, we're going to revisit that on the final. Conics, we're going to have them on the finals. Okay. I want you to pay attention to this new stuff. Okay. Circles, ellipses, hyperbolas, parabolas, you name it. Using the formula midpoint and distance is important. We definitely have questions regarding those. As far as sequences and series, we started defining it. Sequence simply refers to a list of numbers, and it could be that it's convergent or divergent depending upon what happens if you take a limit. That the topic is coming up in the next course. Arithmetic and geometric sequences. Basically, in the case of arithmetic sequence, you add a constant. Now, it could be positive or negative. In the case of a geometric sequence, you multiply a constant. It could be a positive, a negative, or a number larger than 1 or between 0 and 1. Okay. So, given a general term, we wanted to find a few terms. That was very simple. Okay. Then finding the formulas, we dealt with the cases that ended up being a known format, arithmetic sequence, or a geometric sequence. In this case, again, we had combination of stuff, and also alternating sequence was discussed. The recursive format, one, particular formula which is very famous is the Fibonacci sequence. And if you have a recursive sequence, you can find the terms as long as you are given enough information. For example, in part A, all we need is the first one. Whereas in part B, because it's of D, they call it of the recursive sequence of first degree, whereas part B, you need 2 of it, of the second degree. Summation was discussed. We used the summation notation. We simplified some examples involving those. Arithmetic sequences were discussed again, and some examples we looked at. Now it's important to remember the formulas. A sub n is a sub 1 plus n minus 1 times d. And a sub n is n over 2 times a sub 1 plus a sub n. And we looked at this example. We had a couple of examples, interesting examples here. And we should have no problem handling questions similar to this. So we are going to continue from here on. I believe this was the last page we did. So let me stop the video so it makes it easier for the recording. And we are going to continue from here on. And again, this page was done, so we're not going to take time to go over that. Just a quick recap. In the first example, we are given the sequence. All we have to do find the first term and the difference, and we can find the result. In the second example, we are given a specific term, in this case, the 8th one and the 16th one. We went through the process of finding the first term and the difference using systems of equations, and everything else becomes a simple case, and we can easily find the sum. Remember, the sum has two formulas, class. Okay, you can use this formula if you have the first and the last term. If you only have the first term, you use the second one. That's extremely important for everybody to know. Okay, so here's a similar example. So we have the sum of the first 17 terms given to us as 187. A sub 17 is also given to us, and we are to find a sub 1 and the difference. So we can start with this formula. S sub n is n over 2 times a sub 1 plus a sub n. Because n is 17, okay, n is given as 17. Practically, we're done by just plugging in. So S sub 17 is 17 halves times a sub 1 plus a sub 17, and a sub 17 is given. Replace it, you can find a sub 1. This is a very simple process, everybody. I'm assuming everybody can handle this simple case. Okay. So you multiply both sides by 2, you divide by 17. Okay, so in other words, you multiply this one by 2 over 17, okay? When you do that, 17 halves goes away, and 2 over 17 times 187 gives you 22. And a sub 1 becomes 35. Now, we use this formula. A sub n is a sub 1 plus n minus 1 times d. What is a sub n? A sub 17 is given. So plug in. And we already have a sub 1, right? We found it. And so you can find the d, the common difference. I hope it makes sense. I hope everybody's okay with that. All right, we're going to move on, class. Here's the next one. A mosaic tile floor is given. Could somebody read the question for us, please? Okay, anybody want to read the question for us?
I can do it.
Please.
A mosaic tile floor is designed in the shape of a trapezoid, 30 feet wide at the base and 15 feet wide at the top. The tiles, 12 inches by 12 inches, are to be placed so that each successive row contains one less tile than the row below. How many tiles will be required?
Thank you so much, Thalia. So let's see how we handle that. The idea is very simple. we have to add 15 all the way to 30. Everybody understands that, right? Because the smallest one is 15, okay? And the other side, the larger side is 30. So that's the idea behind that. So because we are adding one, if you will, if you go this way, we are adding one, right? We are adding one. The difference of one. If we go up, we are subtracting one. D is negative one, okay? If we are going down, the difference is positive one. And which one are you going to choose? Who cares? Makes no difference. Now, what I want you to notice, the difference is either 1 or negative 1, whether you call. So if you go this way, D is 1. If you want to go that way, D is negative 1. So if you're going down, okay, your first term is 15. If you're going this way, your first term is 30, okay? And you can even try the second. It doesn't matter. The distance or the difference is what it is. Now, how many rows do we have? It's really 30 minus 15 plus 1. I hope you see that there are 16 rows. When you start from 15 to go to 30, let me make sure everybody understands how it's really calculated. The end points, you subtract them, 30 minus 15. And then you add 1. Okay? So if you are going from, let's say, 10 to 100, 100 minus 10 is 90, and then you add 1, because you have to count the first one also. Okay? Now from 15 to 30 is enough, is simple enough, you can count one by one. But what if the numbers become large? So I want to make sure we understand. For example, the first one is 10, the last one is 100. Now I have to count to see how many you have. So the upper one minus the lower one plus 1, that would be the number of rows, if you will. In this case, n. Okay? I hope everybody is clear on that. So we are going to use one of these formulas. Remember that, right? I'm going to call it number 1 or number 2. And because we have a sub 1 and a sub n, it is easier to use number 1. So we use s sub 16, if you will. The first one is 15, the last one is 30, and take it from there. No matter how you look at it, this is the process of finding it. But the only reason I mentioned the D, and it doesn't come to effect here, I want you to see how you approach that. From small to large or from large to small, okay? Needless to say, everybody knows that 12 by 12 inches, that means 1 square foot. That's how we know it's 1. All right. So that's the idea behind summation here, an application of that. Here's the next example. Here's the next topic. We discussed the geometric sequence, and again, we have the following formulas. The general term, and normally we want the first one. I want you to know that, at least in this course. Later on, you may need the second one in other courses, which is an implicit format, if you will. The first one is the explicit format. A sub n is a sub 1 r to the power of n minus 1, and s sub n is a sub 1 times 1 minus r to the power of n over 1 minus r, as long as r is not 1. Now something interesting happens in this case. And we can, by the way, the proof, I have put the proof for you somewhere if you want to study that. If r is between -1 and 1, this thing becomes very interesting. I'll show you as we come across it in a moment. All right, so here's an example. How much will be earned on day 20 if daily wages in cents follow the sequence 1, 2, 4, 8? In other words, we are doubling. How much will you have earned altogether after 20 days? Okay, let's just make sure everybody understands. We're just getting 1 penny. And then it becomes 2 pennies. And then 4, and so on and so forth. This really shows the power of exponents, okay? It may not look a lot, but let's see what happens if we do the geometric sequence. Obviously, everybody can recognize that this is a geometric sequence. And when you claim it's a geometric sequence, you got to come up with 2 things. What is my first term and what is my ratio? And it's very obvious that A is 1. Sometimes they just call it A class, okay? And in some instances, even A sub 0. But as far as we are concerned, we can say A sub 1. The very first term is number 1, and the R is 2 because it gets doubled up. I hope it is clear to everybody. And so on day 20, we want A sub n. So we are going to use the first formula at the very top. And we want A sub 20. So we are going to use the first formula where A sub 1 is replaced with 1 and R is replaced with 2 and N is replaced with number 20. So on that day, 20 days, okay, later, if you will, on day 20, this is the amount that we're going to get in cents. And it's $5,242.88. Okay. Imagine 1 penny. 1 penny, and it's doubling up. This is the power of mathematics and exponentials. Now, what about the total amount we are going to have from day 1 to day 20? Then we use this last formula, S sub n is A sub 1, which is 1, times 1 minus r to the power of n, or 2 to the power of 20, divided 1 minus r, or 1 minus 2. Again, obviously the denominator is -1. I hope you realize the top is really 1 minus 2 to the power of 20, because that's one. And it becomes negative, divided by negative becomes positive, and that ends up being $10,485.75. Okay, so 1 penny is the starting point. 1 penny is the starting point. Okay, class, that sounds good. Any questions? All right, here's the next one. Now we know that we have a geometric sequence. So the third term and the sixth term, okay? We want to find R and A sub 1. So one easy way is just look at the top right formula in blue. That's the nth term. So we write the nth term for n equals 3 and for n equals 6. When we write it, here's what happens. For n equals 3, a sub 3 is a sub 1 r squared. For n equals 6, a sub 6 is a sub 1 r to the power of 5. And we know what they are equal to. Okay, very straightforward. So I want you to see this. So what are you dealing with? System of equations in two variables. So you can even ignore this part. Let's just do this. In essence, you are dealing with these two. Are you with me? A sub 1 and R. So I hope you see that if you divide the top by the bottom or the bottom by the top, A sub 1 goes away. I hope you see that. So to make it easier, we're going to divide the bottom by the top. Bottom by the top. And so A sub 1 goes away. And you end up with R cubed. And that's 8. And R must be 2. So if R is 2, you use one of these equations, okay, class? For example, this one, A sub 1 times 2 squared equals 20, okay? Remember, this is A sub 1 times 2 squared, which is 4, equals 20. And that gives us the value for A sub 1, which becomes number 5. Okay, sounds good, everybody?
Yes.
Perfect. All right. All right, the topic that is interesting to look at here regarding geometric sequence is the following. The limit of S sub n as n goes to infinity is the limit of a times 1 minus r to the power of n over 1 minus r as n goes to infinity equals a over 1 minus r if r is between negative 1 and 1. Okay, if that is the case. Now, I have the proof here. You can go over that, class. This is the proof. But it is important to know when r is between negative 1 and 1, it works out that instead of using the summation, so let's look at the summation at top. This is the summation we did in general. This is the formula for the summation of a geometric sequence. So what happens when r is between negative 1 and 1? What happens is r to the power of n gets smaller and smaller, and eventually it approaches 0. That's why we get a over 1 minus r. So when r is between negative 1 and 1, it simplifies to a over 1 minus r. You need to know that. We use this a lot in calculus. Okay. And again, we look at this. Understand, if you look at this piece, class, r to the power of n, when r is between negative 1 and 1, as n gets larger, r to the power of n gets smaller. Just to give you an idea. If you have 2 and you square it, it becomes larger, becomes 4. If you cube it, becomes larger, becomes 8. But if you have 1/2 and square it, becomes smaller, because 1/2 squared is 1/4. If you raise it to the 3rd power, okay, so here's what happens. Class 2 squared is 4, larger than 2, and it continues. But if it's 1/2 squared is 1/4, which is less than 1/2, it's getting smaller. And then 1/2 cubed is equal to 1/8. It's even smaller. So as n gets larger and larger, this thing gets smaller and smaller, eventually goes to 0. So this top thing changes to 1 minus 0, which is simply a over 1 minus r. So we have a lot of applications for that. So I want to discuss a couple of questions here quickly, and we go to the next topic. So here's an example. We want to add these terms. We want to add 1/2, 1/4, 1/8, so on and so forth. So what you need to realize that this is a geometric sequence. It's a geometric sequence. Now, if it's a geometric sequence, what is its first term? 1/2. What is its ratio or R? Divide 1/4 by 1/2. Okay, and that gives you also 1/2. So in essence, A is 1/2 and R is 1/2. I hope you see that to get to the next term, you have to multiply it by 1/2. Okay? All right. So therefore, we can use this formula to do the math. So the sum, no matter how big it becomes A over 1 minus R. A is 1/2. 1 minus R is 1 minus 1/2, and I hope everybody knows that this is 1/2, and the result is 1. Okay? So when you add them up, no matter what, no matter how many times, ultimately the answer is 1. Okay. Another interesting example would be this. Express this number as a rational number. And there is an algebraic method, you may remember it from algebra, but we want to look at it from a geometric sequence point of view, okay? And to do that, first we need to understand the meaning of the bar. The bar means the number repeats itself. Everybody knows that. So in other words, 0.46 bar means 0.46 indefinitely. And what it means is that we can add up as follows. Okay, let me just continue with what I wrote in a different color, of course. This is class the same as writing 0.46 plus 0.0046 plus 0.00046, and it continues indefinitely. It may make it easier to write it as a fraction. I don't know. You make a decision. Either way is fine. You can keep it as fraction or as decimal. It's absolutely fine. What you need to notice, you are dealing with a geometric sequence. The first term is 46 over 100 or 0.46. R is 1 over 100. And because r is between -1 and 1, we can use s sub n as a over 1 minus r to come up with the answer. So a is 46 over 100. R is 1 over 100. Remember, you multiply the first one by 1 over 100, you get to the second one, and you keep on repeating. And so if this is the case, the top number is 46 over 100. The bottom is 1 minus 1 over 100. This is a complex fraction. If you multiply it by 100 over 100, it simplifies. The top becomes 46. The bottom becomes 100 minus 1. So the answer is 46 over 99. 46 over 99. I hope everybody's okay with that. In algebra, we let that equal x, and then we multiply it by 100. And then we went through the process of solving it. I don't know if you remember that, if you've seen that or not. In algebra, many years ago, they would go with let x be the number. Okay, and then the reason they would multiply it by 100 because there are two bars. The bar is at the top of 2 digits. If it's at top of 1, then you have to multiply by 10 or 100 or 1000 or whatever that you need to. If you multiply by 100, now if you subtract the top from the bottom, you can do the math. I hope you see that. If you subtract the top from the bottom, you get 99x equals 46. That's your answer. This is how we did it in algebra. I hope you remember that. And this is the geometric sequence. All right, let's look at the last question involving the geometric sequence, an application question. Here's the next one. Could somebody read the question for us, please?
The first swing of the pendulum is 25 centimeters. If each swing is 75% of the preceding swing, how far does the pendulum travel before coming to a rest?
Thank you so much, Mercedes. Okay. I hope you realize, in essence, you are dealing again with a geometric sequence. And why is it a geometric sequence? Because if the first one is 25, the next one is the same thing times 0.75. And the next one is the same thing times 0.75, 0.75, and it keeps on going. So you are dealing with a geometric sequence with A being 25, so it's a geometry, A being 25 centimeters, R is 0.75. And the reason we can use this formula because R is between -1 and 1. Otherwise, we couldn't, okay? So basically, the top is 25 centimeters, and the bottom is 1 minus 0.75. Well, 1 minus 0.75 is 0.25, and when you divide 25 by it, it gives you 100 centimeters. Okay. All right. Let's go to the last topic. Here's what we have. We're looking at factorial symbols and binomial theorem. I hope you remember this from algebra. All of this is covered. There is nothing brand new here, class. Okay. So Right now, take a look at how we deal with this simplification. First and foremost, when it comes to factorial, the definition is what you see here. Okay. This is called combination. And there are three ways to write them. N comma R, just like you could write a pair. C and R or the parentheses. So this is 1, 2, 3 different ways of writing them. They all mean the same thing. The calculator uses this NCR, by the way. Okay, NCR. And it is n factorial over r factorial times n minus r factorial. Okay, so that is a combination formula. Now, if you want to simplify something like this, you don't want to write this as 12 times all the way to 1, 10 times all the way to 1. You look at the one that is smaller. 10 is smaller than 12. So you keep that intact. Now the top 12 factorial, we can write it as 12 times 11 times 10 factorial. They cancel each other, and you end up with 12 times 11. Okay, 12 times 11. I just want to make sure everybody remembers that. Okay, so this is the synopsis of what we want to cover here. And the last thing is the binomial theorem. I want to just remind you of what you've seen. X plus a to the power of n, n0, x to the power of n, n1, a, x to the power of n minus 1, so on and so forth. To give you an idea, when we did, let's say, x plus y squared, we know the answer is x squared plus 2xy plus y squared. This is the case where n equals 2. X plus y cubed, this is where n equals 3. It's x cubed plus 3 x squared y plus 3x y squared plus y cubed. I'm going over an identity that we've gone over in class, and I hope you remember that. But this is really coming from the binomial theorem. Okay, class? Now, let's see how we evaluate those. I want you to see how they are done. By the way, 0 factorial is 1, 1 factorial is 1. 0 factorial is 1 because really combination of n pick 0 becomes 1. That's why. Sometimes they call it by definition, but actually there is a better way to approach that. In any event, how do we evaluate those? We just plug in. Okay. So based on the formula at top, combination of 4, choose 1. So n is 4 and r is 1. So you are going to go with 4 factorial over 1 factorial times 4 minus 1 factorial. 1 factorial is 1, you don't have to worry about it. 4 minus 1 factorial is 3 factorial. Okay. And so what we do, because the bottom has 3 factorial, the top we write it as 4 times 3 factorial. So they cancel each other. We end up with only number 4. Okay. All right. Let's look at the next one. Okay. Now we are dealing with 5, 3, which means combination of 5, choose or being 3. All right. So n is 5, r is 3, 5 factorial over 3 factorial times 5 minus 3 factorial. Okay. So the top is 5 factorial, the bottom is 2 factorial. Notice what we do. Because 3 is larger than 2 factorial, we keep it. And we write the top as 5 times 4 times 3 factorial. 2 factorial, you can leave it as 2 or 2 times 1, it doesn't matter. So now you're dealing with 5 times 4, which is 20, divided by 2, which is 10. It's that simple. So this is a faster way to simplify this stuff, okay, class? Okay. This is part C, 7, 5. Okay. Now what do? Same thing. N is 7, R is 5. Do the math. Seven factorial over 5 factorial. 7 minus 5 factorial. Obviously, this is 2. So again, we keep the 2 factorial and we get rid of the 5 factorial by writing 7 factorial as 7 times 6 times 5 factorial. So they cancel each other. And the denominator is 2. 6 and 2 cancel each other. 3 times 7, 21. Okay. Sounds good. Everybody okay with that?
Yes.
Perfect. All right. I hope this calculation is really not difficult for anybody because I think it's pretty straightforward. Okay. Couple of things that may be interesting to maybe show right here is as follows. If you have Cn0, by definition is n factorial. Zero factorial, n minus 0 factorial, which is n factorial. 0 factorial is 1 times n factorial, so everything cancels out and we end up with 1. So that's one thing that you can see, you probably remember it from before. Another one that is helpful, Cn1, that means n factorial over 1 factorial times n minus 1 factorial. Okay, so what you're really, 1 factorial is 1, so you don't have to worry about it. What is n factorial? divided by n minus 1 factorial, this is equal to n because the top is n times n minus 1 factorial. So Cn1 is n, meaning C5.1 or C10.1 makes no difference, or C anything, N1 ends up being N, okay? This being N ends up being 10, this is 5, and that would be helpful when we do the calculation. So with that being the case, let's look at a binomial theorem, which we have it at the top. In other words, you should know that this is always 1 and this is always n. So whatever this one is, okay, this is also 1. In fact, what happens is that the left side and the right side, they have the same coefficient, okay? And it varies if x and a have the coefficients, some coefficients themselves. So I'm going to look at this example and see how this thing is developed. So by definition, you have this 4 because the exponent is 4 here, class. So n is 4, okay? So with that being the case, 4, 0, and you really have to be very careful when we do that. I've seen students writing 3y to the power of 4, which is going to be completely wrong. Now, when I said this one is 1 and this is one class and so is this one, you don't even have to calculate it. In general, C n0 is equal to Cnn equals 1. Okay, so that helps. Okay. Or this one, for example, is 4. Okay. And I've mentioned it as to y, right? We've seen that in the previous page. Now, C42, you need to calculate. Okay. The other thing that is important to know is that this one is also 4 because this is 4. Now, maybe I want to write this for you. This is a theorem, CNR, and I want you to look at it. In fact, I want you to prove it for yourself. And CN n minus R are the same. Here's an example. If you have C, let's say 10, 2, it's the same as C 10, 8. Look at the two numbers at the bottom, they add up to n. Do you see that? I hope this helps, okay? So the two numbers at the bottom, they add up. All right. So with that being the case, here's the next line. Okay. And here's the final answer. Let me just go back to it. Okay. Now, it's important to know that 3 to the power of 4 is 81. That's how we end up with 81 y to the power of 4. Okay. So then 4 times 2 times 3y cubed is 27y cubed. And that's how we end up with 216y cubed. Okay. Now, 4, 2 ends up being 6. You can show that. And then 2 squared is 4. 3y squared is 9y squared, and so on and so forth. And this is the final answer that you have. So I hope everybody is following and everybody is okay with this. Is there any questions so far? All right, before I go to the last question, I want to make sure everybody understands that the reason these things don't end up having the same number. If you look at this one is because when you go back to the original one of them had 3y, one of them had 2. If by any chance we have something like this class, let's say x plus y to the power of 10, then the very first term and the very last term, they have the same coefficient, okay? And notice and with that, the way the exponents work, in one case goes up, in one case goes down, okay? So the first one starts with n. Okay, I'm going to write this. I'm not going to finish it, but I'm going to write this. So take a look at what happens, the one I just wrote up there. Let me just erase this. Okay, so if I want to expand this, if I want to expand this, now it's n0 or cn0, and I know cn0 is 1, so I'm not going to bother writing cn0. So it's 1, so you get x to the power of n plus, I'm looking at this one. Then n1, that means 10, 1, I know that is 10. It's 10. So here's what happens. X goes down and y goes up. Notice the exponent, my apologies, this is 10. This one is 10 class. The exponent for the first one is 10. For the second one also, they add up to 10. Now, the next one I need to calculate. I'm not going to calculate. I'm going to show you that it is C10(2). You have to calculate it. Now, x goes down. And y goes up as far as their exponent is concerned. Okay, and this thing continues. And so I want to write the last one first, so it becomes y to the power of 10. And the one before that, now, again, it's 10. Okay, because it's C10(9). I want you to know what this is C10(9), and ends up being 10. Now we have x and we have y, but y has a larger exponent, which is 9. I hope you see that. That's how it's done. And in between. Okay, class? Whatever you have to write. Let me write one more. I want to make a point. There is, if I were to write another one here, I would write C10. Let me see, I may need more room. C10, 8, x to the power of 9, because x to the power of 8, y squared. Now what matters is when you do the calculation, C10(2), you calculate, then it's the same as C10(8). You don't have to calculate both of them because remember 8 and 2, they add up to 2. So that's an interesting piece to remember. Okay. And so here's the last one. Find the 7th term in the expansion. You have a choice. You really can go to the 7th one and figure it out. Or based on what we just discussed, you may see this formula. Okay, you look at the one I did in the previous page for you. Okay, so based on the expansion, the term containing x to the power of j is n over n minus j, a to the power of n minus j, x to the power of j. I want you to go back to your notes, take a look at what I did in the previous page as I was expanding something and I was showing that to you. Okay, so we want the 7th term. Okay. And so remember, you have 8 terms. So we can use the 7th term in the following manner: 8, comma 6. Okay. Remember, the very first term is y to the power of 8. Okay. And the very last one is just a constant, if you will. In other words, it starts with y to the power of 8. Okay. And you have a bunch of stuff, and you have 3 to the power of 8 at the end. Okay. So we don't want to expand this from A to Z. Okay. We are looking at this concept that we want one of the terms. Okay. And it's important to know this is your first term, everybody. And this one is n plus first term. So this one is the 9th term. Okay. So if we have an exponent 12, we end up having 12 plus 1 terms. That's the idea. Okay, class, I want everybody to follow that. So however many n is, you add 1 to it. Okay. So the 7th term is like 2 before that. So there's one more before 3 to the power of 8 and one more. That's why we have 8, 6. That's why we have this one. Okay, and it's explained here. And so you have to calculate that. That's 8 factorial over 6 factorial times 2 factorial. Then y squared and 3 to the power of 6. Okay, and it's important to see that everything gets square, gets powered up accordingly. Now, of course, if we want to simplify this, remember what happens. 6 factorial is kept, and the top becomes 8, 7, 6 factorial. Okay, and so when we drop that, they cancel. And by the way, 2 factorial is the same as 2, class. So you can easily simplify this one with this one, which is 4 times 7 times 729 y squared. And that is the final answer.